Hey, so today we're going to talk about exponential functions that involve a percent. So if you are going to make money and it says something about an annual growth rate, then you know that that's a hint that it's an exponential function because it's going to make that percent of the amount you have in the account that year each year. So remember that for an exponential function, we use the formula y equals ab to the x power, where a is our initial value and b is our growth rate. But in this case, when we have our percent, we know a little more information about b. We said that in that case, we're going to use y equals a times 1 plus r to the t, where r is that rate. We just have to have it as a decimal, and t would be our time. So if we read this question, it says, on the day Alexander was born, his father invested $5,000 in an account with a 1.2% annual growth rate. Write a function a of t that represents the value after t years after Alexander's birth. So in this case, they're telling us to use a instead of y. So we're going to put a of t. Remember that the a in our equation is our initial value. And so if I read this question, initially, right, his father's going to invest $5,000, so that's going to go out front, my exponential function. And then it's 1 plus r to the t. In this case, r is 1.2%, but we need to have it as a decimal. So I'm going to take that 1.2, and a percent means out of 100, so I'm going to do divided by 100, which is 0.012. So that's what I'm going to substitute in for r. And if you remember when we did functions, here a is our dependent variable, which makes t our independent variable. So I'm going to put t here. So this is our equation for our function. Then it says determine to the nearest dollar how much more the investment will be worth when he turns 32 than when he turns 17. So that's really just our time. So the first thing we'll do is say, okay, well, how much will he have when he's 32? And we'll substitute in 32 for t. In that event, if we do that, we're going to get 5,000, 1.012 to the 32nd power. And we can put that in our calculator. And when we do that, we get 7323.967. Remember, money has two decimals. The 7 is more than 5, so we have to add 1 to the 6. So after 32 years, that $5,000 will now be $7,323.97. It might not sound like a lot of money, but that's not too bad, considering he only invested $5,000 and all the rest of that money was free. And then we would do the same thing for when he's 17 and put that in our calculator. And in this case, again, we're going to cut it off after the 4. The 9 is bigger than 5, so we're going to add 1. So in the end, if it was only 17 years, we would get 6124.05. And then it says how much more, right, would he have when he's 32 than when he's 17? So I want to basically just find the difference here, so I would subtract them. So he would make $1,199.92 more when he is 32 than when he was 17. We could do one more example of this. So here's another question, right? Dylan invested $600 in a savings account at 1.6% annual interest. He made no deposits or withdrawals. The interest was compounded annually. Again, compounded means that it adds up each year, so I'm not going to make 1.6% off 600 every time. It'll make it off the growing amount of money, which tells me it's exponential. So I'm going to use that same formula, right? Y equals a parentheses 1 plus r to the t. So in this situation, he invested 600. So this would be our starting amount. So we know that we started with $600. And then the rate is 1.6%. So I have 1.6%. Percent means out of 100. So I'm going to divide by 100. And I get 0.016. It's very important we know the decimal's in the right spot. A little shortcut is you can move the decimal 2 places to the left, but just be careful with that and make sure you do fill in the place with a 0, or you're going to have too much interest in your answer. So here we have our 0.016, and it says for 2 years, so that will be our exponent, and at that point we can just type this in our calculator. The number we get is 619.3536, but again it's money, and then this 3 is less than 5, so we're going to leave this one alone this time, so we'll have $619.35. Now the question doesn't ask it, but what might be helpful for your project is to figure out how much net money we made. So in this case, if I already put in 600 of my own money, right, and I have 619.35 now, I would take my original amount and I would minus the $600 that I personally put in, and I find out that that means that I invested 600 of my own money, but from that investment, right, I made $19.35 over those 2 years, right? So it's also good to analyze how much did I actually make. And so this would be like our net gain, we could call that, right? The amount of money that we got in total. And you can use that as an example as you analyze the different options in your project. I hope this helped you set up equations with percents a little better. And if you have any questions, as always, you could reach out to us. Thank you.